Hi guys, so in the previous video we discussed the definition of intermolecular forces, ID forces and PD forces, and in this video we're going to be talking about the last form of intermolecular forces, which is hydrogen bonding. So as I talked about previously, these are the strongest intermolecular force of attraction that you can have. Now covalent bonds are going to be stronger than hydrogen bonds, but PD forces and ID forces are going to be weaker. So the definition of hydrogen bonding is that it's a force of attraction between an electron deficient hydrogen and the lone pairs of a highly electronegative atom. And in this case, we look at only FON, which is fluorine, oxygen, and nitrogen. Now the question arises, why FON? Why do we only look at fluorine, oxygen, and nitrogen? Now there are two reasons for this. The first one is that they're the most electronegative, and the reasons for that have been discussed in the video on electronegativity and polarity. So if you're confused about that, you can check out that video. And the second reason is that they have the highest charge density. Now, charge density is going to be charge divided by volume. So these atoms are going to be the smallest, so their volume is going to be the least. So because of that, the charge density is going to increase. And both of these factors are going to lead to hydrogen being highly electron deficient, so it's going to be able to attract the lone pairs and hydrogen bonds are going to form. After this, we're going to be taking a look at the diagrams for hydrogen bonds. So there's a series of steps that you need to follow. The first thing that you're going to do is you're going to draw out whatever molecule you have. So in this case, it's hydrogen fluoride, so you're going to draw it out. The next thing that you're going to do is you're going to show the lone pairs. So in this case, there are going to be 3 lone pairs on fluorine, so you're going to make those. After that, you're going to put the partial charges. So in this case, fluorine is more electronegative than hydrogen, so it's going to have a partial negative charge, and hydrogen will have a partial positive charge. After this, since hydrogen bond is a bond between an electron deficient hydrogen, which in this case is going to be this hydrogen, and the lone pair of a highly electronegative atom, which is fluorine. So you're going to make a dotted bond. So just to recap, you have to show all the lone pairs. You need to put the partial charges on all the molecules that are there. You need to show the dotted bonds. And it's always advisable to show just 1 to 2 hydrogen bonds unless you've been told to do otherwise in the question. Now let's look at another example, which is water. So in this case, oxygen has 2 lone pairs, and these two hydrogens are going to be electron deficient. So the first thing that you're going to do, you're going to mark the partial charges. So oxygen is going to be partial negative and hydrogen is going to be partial positive. And then you're going to make the lone pairs and you'll make the dotted bonds. So this is just showing 1 hydrogen bonds. You can have multiple. The next example that we're going to be taking a look at is methanol. So in this case, these hydrogens over here, these will not take part in hydrogen bonding, because for hydrogen bonding to take place, the hydrogen needs to be bonded to a fluorine, an oxygen, or a nitrogen, as you saw in the previous slide. Since these hydrogens are bonded to a carbon, they will not take place in hydrogen bonding. However, this hydrogen is bonded to an oxygen, so because of that, it can take part in hydrogen bonding. So you're going to make the lone pairs. Since oxygen has 2 lone pairs, you make 2 lone pairs over here. Then you're going to mark the charges. So oxygen is partial negative and hydrogen is partial positive. And then you're going to do the same thing on the other molecule and you're going to make the dotted bond. So this is how you make the diagrams for hydrogen bonding. Now we're going to look at 2 important questions. The first one is ethanol soluble in water? So ethanol is soluble in water because ethanol and water can both form hydrogen bonds with each other. So if you have any 2 molecules that can both exhibit hydrogen bonding, they will be soluble in each other because they can form hydrogen bonds with each other. So now let's look at how this happens. So over here, this is a molecule of ethanol and this is a molecule of water. So like we did in the previous slide, we're going to mark the lone pairs. And after that, we're going to put the partial charges on the oxygens and the hydrogens. And then we're going to make the dotted bonds. So this shows that ethanol and water can form hydrogen bonds with each other. And then it reiterates the fact that ethanol is soluble in water. Now the second question is, why is ice less dense than water? So normally, if you have any solid, it's going to be more dense than the liquid of the same substance. However, ice is an exception. So we're going to be discussing why this is. Now in ice, the molecules are going to be hydrogen bonded with each other in a tetrahedral arrangement. So this is the tetrahedral arrangement. And there's going to be large empty spaces, as you can see over here, there are large empty spaces. So because of that, the volume will increase. And since volume and density are inversely related, the density of ice will decrease. So the reason why ice is less dense than water is because of the structure of ice. Since it's tetrahedrally arranged, there's going to be a lot of empty spaces which will increase the volume and decrease the density. In liquid water, there are 3 to 8 membered rings which are constantly being remade and broken. So because of that, there is no fixed arrangement. In ice, there is a fixed tetrahedral arrangement. In water, the arrangement keeps on changing, which is why ice is going to be less dense compared to water.